All right. Hello, everybody. Hello again. I hope you guys had a really good clinical rotation. Did everybody have anything interesting in your clinical rotations you might want to share? If not, we can talk about that tomorrow. Last week, I sent you a whole bunch of information. As you can see, we're going to be covering almost 200 organisms. Not only bacteria, we're going to cover AFB, which is still kind of bacteria, but it's just acid-fast, different characteristic. We're going to cover mycology, the funguses and the yeast. And the last section, which is a pretty big section, is parasitology. And parasitology is the biggest section, and we'll get through it. Like I said, a lot of comments from previous classes, even before I taught this class. Microbiology has a ton of information that's given out. So compared to hematology, microbiology is much more, a lot more information, but we'll get through it together. So let's see. So what I did was I gave you an instrument list of what we're going to cover and in each of the topics. Like, for example, so that way you guys won't be confused. So the first two lectures are safety 1 and safety 2. This is really important. I know you've had safety and QA and a lot, QC and infection and precautions in the laboratory, but these two areas are really important. So this is today, and then tomorrow I'll be doing safety lecture number 2. And then on Friday, and then I'm going to start getting into the Micrococcaceae, and that includes Micrococcus and the staphs, and I'll teach you how to distinguish between the 4. And then after that, the following Wednesday, it's starting to get more in depth with the streps. Strep group A, which is Pyogenes, Strep A galacti, Strep pneumo, Viridans strep, and the group D Enterococcus and group D non-Enterococcus. So you have a table and that'll help you distinguish between these strep groups. I know a lot of times I'll say it should be easy to do. I don't know what your level of knowledge in these organisms are, but I'll help you distinguish between these 6 organisms. And then the next section is the Enterobacteriaceae, Enterobacteria. This is a much larger group where these are all your gram negatives, everything that can be found in your gut. Proteus vulgaris, Proteus mirabilis. I hope these names are not unfamiliar. I hope you've heard these names before. Salmonella, as you know, is a pathogenic. It's reportable to public health. So is the Shigella. We're going to go over those, especially biochemical distinctions between these organisms. I'll be giving you flow charts between the 4 Ewing groups. And then you've heard of the pathogenic E. coli. There's 5 of them here. And it's not only you hear in the news that there's a pathogenic E. coli that's been toxic in like in Jack in a Box or in some restaurant where it caused food poisoning and the culprit was E. coli 0157. You always hear about E. coli 0157. That's the enterohemorrhagic E. coli. So these are the 5 classes. ET is enterotoxigenic. EI is enteroinvasive, enterohemorrhagic, like I just mentioned, enteroaggregative, and enteropathogenic E. coli. So it's not only E. coli 0157. There's like 5 different ones. Shigella, as opposed to Salmonella, when you do a stool culture, the 2 main pathogens that you look for in stool, your objective when you're on the stool bench is to identify Salmonella or Shigella. And there are other pathogens there too, like Yersinia, Yersinia pestis, Yersinia enterocolitica. That's not very common, but the Salmonellas and the Shigellas are more common and more pathogenic, and they're also reportable to public health. I'll tell you how to distinguish between the 4 pathogenic E. coli. There's an acronym that I'll teach you. Yersinia pestis, that's the one that causes the plague. More Yersinia. Klebpneumo. Klebpneumo is really important in babies, especially in urine, if it's greater than 100,000. So one of the things that I want to do this semester with you guys, as opposed to what I've been doing with other classes, is I want to teach you guys how to read cultures. Okay, so because when you work in a microbiology laboratory, you will be assigned to different benches. You can be assigned to the respiratory bench, you can be assigned to the urine bench, you can be assigned to the miscellaneous or wounds bench, or you can be assigned to the blood culture bench. And then one thing I like about microbiology is if you're assigned benches like that, you can read cultures. If you know and you're familiar with what the plates look like, what's clinically significant and what's not clinically significant, then you'll get an appreciation. And like I said, any specimen that comes into the microbiology laboratory is basically an unknown. So the doctor orders a culture for a reason, mainly because the patient's sick and he wants to find out what's causing his sickness, his illness, what's making him not feel good. That's where you come in as a microbiologist. So it's kind of exciting. I'll show you how to detect from a respiratory culture if you have Haemophilus influenza. And there's later on, that's in a different lecture. But one of the things, like I said, is I want to teach you guys how to read cultures. So when you get into the microbiology, you're not going to only do catalase tests or indole tests or gram stain, set up gram stain. Those are all elementary. Those are all baseline given tests that every microbiologist should know. So this semester, like I said, I want to take it up to a higher level where you're going to get plates in front of you as they are submitted to you in the microbiology laboratory. You're going to say, okay, what's going on? And is it junk or do I do a workup? Is it junk or do I do a workup? So I'll show you how to identify whether or not a culture is junk, because there's a lot of skin flora where it's not acceptable, and pure cultures I can show you what a good workup cultures looks like. Klebs, Klebpneumo versus Kleboxytoca. The difference is Kleboxytoca is indole positive. You'll know that. Enterobacter aerogenes, also part of the Ewing group. We're going to get into the Ewing groups, the 4 Ewing groups, and you'll be memorizing those, and I'll send you the flow charts, and you'll be tested on those. Serratia marcescens, Indian Enterobacteriaceae is the only one that's pigmented. Hafnia is not really common, but it's in one of the groups. And then moving on to the facultative anaerobes, I'll be talking about Vibrio cholera. Okay, Vibrio parahemolyticus. These are important pathogens that you need to know how to work up. Aeromonas, a trick on Aeromonas. This organism likes ampicillin. Aeromonas A, ampicillin A. So one of the things that Aeromonas likes as part of a culture workup is it tolerates ampicillin very well. Aeromonas likes ampicillin, so A goes with A. So that's the first trick I'm telling you. Plesiomonas shigelloides is found in reptiles. Pasteurella multocida. Does anybody know about Pasteurella multocida? What causes that or disease? It's a common disease, so you'll never forget this. Pasteurella multocida causes cat scratch fever. Okay, cat scratch. So One of the things to be cautious about when having cats. Cats is important in another organism as well, but for cat scratches, which they are known to do, scratching people, you need to be aware that it causes cat scratch fever. Gardnerella vaginalis, you should know what how to identify the presence of Gardnerella vaginalis. Does anybody know what you would see in your analysis?
Clue cells.
Blue cells is right. So the difference between, and these are, when you look at a urine sediment, one of the things you look for is that you look at the epithelial cells. If the epithelial cells look rough and gritty, it's rough and gritty because the Gardnerella has obliterated that epithelial cell. So that's how you know. And also too, it has a characteristic odor, but we can get into that when we get into this lecture. And then there's a facultative GNR number 2. Campylobacter jejuni. Campylobacter species has distinctive morphology. It's called gram-negative seagulls. They look like seagulls. And I'll show you that. I can draw it for you tomorrow in the lab. Haemophilus. We're going to get into the X and V factors, X requirement and V requirement. X is Heman and V is NAD. So hopefully in the laboratory, we'll get the X and V discs in, and depending on the growth patterns around these discs, we can tell which organism is influenza, Aegyptius, parainfluenza, Ducray, Propolis. H. pylori is also in this group. H. pylori is important because, especially if you want to rule out peptic ulcer. So what will happen is if a patient has a doctor wants to rule out peptic ulcer and he's in the patients in surgery, he'll take a specimen from the duodenum, okay, the duodenum, part of the stomach, and send it to the laboratory. And then we do one quick test, and it's called the Urease Test. So you'll learn that H. pylori, we want to find out if it's there. You do a urea test, and you'll know in a couple hours. So that's a neat thing. And that's where the OR comes into the laboratory. I have a rule out H. pylori. You're not going to say, wow, how am I going to do that? Okay, so the first thing you'll do is you'll get your urea reagents out and do a urease test. If it's urease positive, then it's a pretty good indication that H. pylori is there. Pseudomonas, aeruginosa, fluorescens. This organism, Stenotrophomonas multifilia, I know that's a mouthful. That used to be Pseudomonas multifilia. Okay, but now they call it, I don't know why they changed it, but it's Stenotrophomonas multifilia. I'll talk about those. These are, now we're into the aerobic GNRs, okay? You'll need to know that Enterobacteriaceae has specific characteristics. They reduce nitrate to nitrite, they ferment glucose, they could either be lactose positive or lactose negative, and I'll show you that that's important too. And they're facultative anaerobes, the Enterobacteriaceae. On the other hand, the aerobic GNRs, these are oxidative organisms. They don't ferment glucose, okay? They don't ferment glucose, and they have motility. If they're motile, they have polar flagella, okay? As opposed to Enterobacteriaceae, they have Peritricus. Does anybody know what Peritricus means? Peritricus means that the flagella are all over its body, okay? So all over its body, so that's Peritricus. Peri means around, as opposed to polar, it's on one end of the bacteria. Okay, so anything that's monas or a monad is, one, it could be oxidase positive, and two, it's motility by polar flagella. So that's what you need to know about these aerobic GNRs. Moraxella, Acinetobacter, Chrysobacterium meningisepticum, Alkalinogenies. These are all, I don't want to say weird, but they can be clinically significant. Burkholderia cepacia can cause glanders, and also to the cepacia, the pseudomallei, and the malaria, they can be baroterrorist organisms. And then Legionella, if you ever heard of Legionnaire's disease, that's in this group, aerobic gram-negative rods. It's the one where the American Legion had a convention on a ship, and everybody came down with this respiratory infection. They couldn't figure out what it was. It was a really tiny, light-staining gram-negative rod, and it was found in the air conditioning units. So air conditioning units for Legionella pneumophila. So there are, in this class, you're going to, like I said, you're going to be getting a lot of information on these organisms, and it can be unique. Like, for example, if I showed you an air conditioner, okay, right away, I would like for you to think about, okay, Legionella, or another one, another descriptive term. And what you need to do is you need to start collecting all these unique terms, like, for example, fish scales. If you see fish scales on a blood agar plate, they're shiny, they're gray, and they almost look like fish scales, you need to think about Pseudomonas aeruginosa. I also sent you, similar to what I did in hematology, a matching, comprehensive matching. You might want to start looking at those, because I've already helped you out in getting you your collection. There's a lot of weird things: railroad tracks, grape-like odor, fish scales, mercury droplets, gram-negative seagulls. Okay, so all of those things, there are these terms that it made it sound like, wow, these are weird terms, but they actually are associated with certain bacteria. So start looking at that list and see and look at these weird terms, and associate these organisms that you see with these sections here, like the Enterobacteria, the strep, like, for example, strep pneumo, lancet shape. If you see lancet shape, that's strep pneumonium. Viridans is an alpha strep that's not significant. Group D enero, group D non-enero. The way you distinguish between those two is salt tolerance and growth versus no growth, and 6.5% sodium chloride. So there's a lot. And like I said, as I go through these lectures, and as I lecture, I'm gonna point it out to you. Okay, this is what, and I did this last year in hematology. Okay, make sure you know this, and I'll say, okay, that's a weird term. You might want to put this in your collection. And you already have the collection, because I gave you the Mega Match Comprehensive. So all you have to do is pull it out and put it into either the section of facultative GNR, or even right next to this organism. I mean, right next to the listed organism, like, for example, Proteus vulgaris, Proteus mirabilis. These two are, tell me a physical characteristics about Proteus. Anybody know about anything about Proteus? Did you guys do Proteus in your microbiology class? Proteus is a pain in the butt to deal with, okay? The reason, because Proteus is a swarmer. It's a gram-negative rod, Enterobacteria, but it swarms. And the reason why it's a pain in the butt is because if there's another organism in addition to Proteus, it's difficult to go after that organism, but there's methods. Say, for example, you have Proteus and Staph aureus. I want to go after that Staph aureus because I want to do a sensitivity on it. But if I use my loop, try to get the staph and streak it out for isolation, guess what? I'm going to get more Proteus. But there is a way to eliminate Proteus contamination, and I'll show that to you. But the difference between the two, Proteus vulgaris and Proteus mirabilis, is the indole test. Vulgaris is indole positive. So you'll be getting a flow chart of the Enterobacteriaceae, the Ewing flow charts, and you'll see that how to distinguish between the different species. Okay, moving along. We're still in bacteria. Spirochetes, the syphilis organisms. These are just spirally shaped organisms. T. pallidum, that's the one that causes syphilis. And then Endemicum, pertinu, and Caritium causes Yaz Pinton-Bajel. Those are the diseases of the treponemes. And then there's Borrelia recurrentis, which causes relapsing fever. I'll tell you the trick on recurrentis. Recurrentis sounds like recurring. Relapsing fever also means, or almost sounds like it means recurring. So recurrentis and relapsing go together. So that recurrentis causes recurring fever. Burgdorferi, you already heard about what this organism causes, but not necessarily in depth on the organism. This is the one that causes Lyme disease. Okay, Borrelia burgdorferi is the one that causes Lyme disease. And then we'll go over I'll go over the arthropod vectors. Leptospira interrogans, it's a pretty important organism, especially if you swim in ponds that has this organism and it affects the brain. So leptospirosis is a pretty significant organism. Now we're going to get into the mycobacteria. Mycobacteria are different than the previous organisms that I mentioned, with the exception of the spirochetes. It's better to identify these spirochetes using dark field microscopy as opposed to the gram stain. It's better to see those, but all the other organisms, the aerobic GNR, Enterobacteriaceae, all of those, you need to, if you want to see the organism, you have to look at it under the gram stain. But the mycobacteria, you can't really gram stain because it has, their cell wall has a high lipid content. So you have to do a procedure called the acid fast stain, where it uses carbofusion. There's a cold stain and there's a warm stain. So we're going to do both stains, the Kenyon and the Ziehl-Neelsen. It's where you take a flame and you heat the slide until you see steam, and then you rinse it, and then you look at under the microscope. It's really important to make sure you know that you have acid fast bacteria under your slide, because especially for tuberculosis, if you identify tuberculosis, as you know, it's pretty contagious. So if it's there, and it's easy to identify. If you see anything that's red from the acid fast stain, it's a positive stain. You see red rods, it's positive. So, and usually it's negative. So these are the mycobacterium, and they're distinguished between on their growth patterns, whether it grows. There's slow growers and fast growers. Slow growers is growth after 7 days, and the fast growers or the rapid growers is less than 7 days. So there's ways to distinguish between the bacteria. Mycobacteria 2, Nocardia is an organism that's partially acid fast. The gram-positive rods, okay, those are all acid-fast bacteria and gram-negatives that I just mentioned. The gram-positive rods, Corynea diphtheria. A diphtheria used to be a disease that killed a lot of people. And it's pronounced Corynebacterium, not corny, okay? So if I hear someone say Corynebacterium, you know, I'll roll my eyes and say, okay, that person wasn't listening. It's pronounced Corynebacterium. I'm really particular. I don't know if you picked that up for me last semester, but I'm really particular about pronunciation. Listeria monocytogenes. You've heard about Listeria in the news. That's the one that in dairy products, it can contaminate dairy products like Jalisco cheese or in any kind of cream or dairy products. It can be a pretty significant organism. Erysipelathrix rhiziopathy is another important. Lactobacillus is important too. Probiotics uses lactobacillus. Bacillus subtilis, anthracis, and cereus. These are bacillus that can be used for bioterrorism. If you autoclave glassware, then you use the Bacillus stereothermophilus. That's your indicator whether or not your glassware is sterile or not. And then that's it for the bacteria. Next is the mycology, the different types of funguses. Going to go into the clinically significant Cryptococcus neoformans. I have that. I ordered it in the laboratory. There's a specific way to identify Cryptococcus neoformans. It's because it has a large lipid capsule, and hopefully we'll be doing an India ink prep where you put some of the you have a suspension of the organism, you make a glass a wet mount, and then you introduce India ink, a little bit in India ink on one side of the glass cover slip. And then when you look at it underneath the microscope, if you have Cryptococcus there, it looks like headlights because of that large capsule. Okay, the large capsule will be bright, and if you see a lot of these bright lights underneath so it's really neat to see. You see a lot of these bright lights or bright circles, then that's the Cryptococcus neoformans, and that's called a positive India ink prep. Okay, Candida albicans is an important yeast, causes thrush. It's a very common yeast. It's reportable, and it can cause problems. So we'll find ways to identify Candida albicans. One of the quick ways is called the germ tube test, and I'll show you how to do that. Then Microsporum odwini, we won't handle that. Odwini, Microsporum canis, Trichophyton mentagrophytes. These are all dermatophytes. Dermatophytes are fungal organisms that infect the skin. Like if it infects the head, it's Tinea. Let me see. Obviously, it's not Pedis or Tinea capitum. Okay, Tinea capitum. That means it affects the head. Tinea corporum, it affects the main trunk of your body. Tinea pedis, it's the feet. So these are your dermatophytes. Dermatophytes affect only the skin, your outer layer, your skin. It doesn't get into the deep portion underneath the subcutaneous. And then you can get into okay, these are mostly dermatophytes. But then there's other organisms like Histoplasma capsulatum. I don't see that here. Histoplasma capsulatum, I must have overlooked that. But Histoplasma capsulatum, Coccidioides immitis, Blastomyces dermatitidis, those are the ones, Sporothrix those are your systemic mycosis. Those are the clinically significant mycosis. I'll make sure that they get added onto here because we're going to be, well, there's Sporothrix Coccidioides immitis. Okay, but I don't see the histoplasma there. Those are your clinically significant fungi, and they're dimorphic, which dimorphic meaning that you have a yeast phase and then you have mycelial phase. I mean, on culture, they can produce the fuzzy fungal cultures, or they can produce a yeast form. So there's two types of forms of the organism that exist, the yeast and the fungal form. And then finally, the parasites. So for parasitology, on that section, you're not going to have, and there's 4 sections here, and we're going to go over all of these parasites. But as opposed to the other sections, the aerobic GNR, et cetera, the mycology, et cetera, the Enterobacteriaceae, et cetera, the main thing I'm going to do, I'm going to have you do about the parasites is to identify them. Okay, you're going to be getting color plates. I'm going to show this egg, and you're going to tell me what it is. And so the parasitology is not going to be, you're not going to get a multiple choice portion of the exam, and it's going to be pretty much identification. Okay, then so there's also a mega match too. I think I just sent over, thanks Saray for correcting. I wasn't sure if I had sent the correct lecture schedule. So you should have gotten the lecture laboratory and quiz schedule that I sent. Pardon me?
It's still a hematology schedule.
Are you serious? Because I I looked to see what I sent, and I opened the attachment, and it had microbiology.
The last one is the master for the micro, but the first two, the lecture and activities, are from hematology.
Okay, but did you get a microbiology one? Did you get a microbiology? This is the one you should have gotten. It's called 2022 Lecture Laboratory and Quiz Schedule. And this is the one that I thought that I had sent. Does this look familiar? Does anybody have this? Because I went into my sent file and I opened up the attachment and it showed this. It showed this schedule. None of you have this, right? Okay, I'll send it over again, and then I'll ask for confirmation that you received it. Okay, so this is a tentative schedule, and it's only tentative because, I talked to Daniela early this morning, and a lot of media hasn't come in. So it kind of looks like you're going to be doing a lot of gram stains and spot testing, catalase tests, maybe OF tests. So all these simple tests that we'll be doing in the laboratory, because once the media comes in, then I can tell you and show you what it's going to be really important to know what the organisms look like on blood CNA and McConkey, or blood chocolate and McConkey. Okay, so as soon as I get to the lab tomorrow, then I'll be on Daniela to find out when these things will be in. But gonna have 3 lectures a week. This week will be the 2 safety lectures and the micrococcus, which includes the micrococcaceae like micrococcus, staph aureus, staph epi, and staph saprophyticus. And so these 3 lectures, you'll be getting quizzes here the following week. Okay. What I want to do is give the exam the following, but the reason why I didn't give you an exam here is because you still have strep and antibiotic susceptibility testing this week. So I pushed off your exam, and here I have the topics of your exam: safety, staph, strep, and AST will be the 3rd week. Okay, and then it follows after that. You'll have Entero 1, 2, and 3, and facultative GNR and 1 and 2. So facultative GNR 2 will be Wednesday of this week, but then you'll be also having a midterm on Friday. So hopefully that's not going to be too close. Let me know if that's going to be an issue, because then I can push it to Wednesday. But then I still want, but pretty much on Fridays you'll be getting your exams. Okay, the exams will be here, designated exam 1, and then this will indicate the lectures. So this is lecture 1 through 5. This is lecture 6 through 10, 11 through 12, and so on. And then you'll be getting quizzes. The quizzes may correspond or overlap some of the material and the enzyme in the exams. So if there is overlapping information, then take that as extra credit. Okay. So if you get it right here and you get it right here, then just take it as extra credit or extra points. But pretty much you'll be getting an exam every Friday. Okay, the exams will be Friday. Okay, getting into the parasitology, the quizzes stop. And like I said, for these exams, you're going to be getting a parasitology matching. You'll be getting parasitology case studies. And then I'm going to give you the malaria life cycle. I think I gave you the malaria life cycle as one of the handouts last week. And then there's going to be a mega match exam. And I gave you the master mega match. I'm going to go over that again to make sure. I think I didn't see histoplasma capsulatum on there, but I'll review it. But you'll be getting, if I add organisms to it, then I'll send you an updated one. Okay. And then here, so these are biochemicals here in April. because you'll be done in first 2 weeks in May. We're gonna start. I'm gonna start teaching how to read cultures. So we're gonna be doing that here in the lab, here and here. I'm gonna try to get some cultures. I'll let you know what a CSF culture looks like, a urine culture looks like, respiratory culture, and positive blood cultures. A lot of positive cultures that I'm gonna try to get from one of the laboratories, and then I'm gonna share that with you. And I'm gonna say this is what this looks like. I would work up this colony, and this colony, or I would say this is what this looks like. It's junk. So, for example, a urine culture, a clean catch urine culture has 3 or 4 different morphology, colony morphology types. That's an easy one. That's junk. The rule is if there are 3 different morphology types, then there's a lot of skin contamination there. It's not worth working up. But if it's pure, then you do work up. But I'll show that to you once we get into reading cultures. So that's something that's new, that I want to introduce to you guys, because I don't want you to only know how to do a test. I want you to know how to be a bench microbiologist by reading cultures. Okay, I want you to have that experience. So that way you'll be prepared. You'll be prepared when you go into the microbiology laboratory on what the CLS is teaching you, because a lot of them, it's like, they'll tell you to do a gram stain, do a catalase. Oh my God, catalase. Okay, hydrogen peroxide. They're going to tell you to do all these simple basic tests because you're students. But then once you show interest in what the cultures are, what does it look like, then they're going to want to teach you more microbiology. So that's what my goal is this semester in this class. Okay, so that was a lot to talk about. Any questions so far? It's a lot of information. After I sent all that information to you last week, it's like, oh my God, with all the organisms, it's, like I said, it's almost 200 organisms, and I think some of them are missing, so it's probably going to be 200. You guys are going to learn about these bacteria, fungi, and parasites, and you're going to have information overload by the time you finish this class. And you know what? You guys will do well, because traditionally on the ASCP exam, students from this program, they score the highest points in microbiology. So all this information that you're going to be taking in, you're going to be seeing it on your board exam, and then you're going to be answering those questions. So on average, the average score, I believe, on the ASCP exam is between 700 and 800 points. So whereas in other areas, unfortunately, hematology is, they score in the 600s and the 500s, 600s, 500s, 400s, but microbiology is typically in the 700 and 800 score group. So you'll get a lot out of this class, and hopefully the information. But like I said, in other classes, they input from the students. It was almost kind of like a complaint that, it's way too much information, way too much information. But you know what? They could ask you a lot of this information on your board exam. So take good notes, start a collection. Like I tell all the other classes, start a collection of weird characteristics. Like I said, gram-negative seagulls, fish scales, grape-like odor, grape appearance, pairs and chains, lancet shape, mercury droplets, things like that. Okay, those are let me see, kidney bean shape. That's another common one. If you see kidney bean shape, then that's very characteristic of certain organism, kidney bean shape. Okay, so start your collection of weird terms and weird descriptions and media. Okay, media is another thing. On what's the media of choice? Make sure you start collecting media of choice of certain organisms. Let's see. Like I have a matching exam. So match the following characteristics with the organisms. And here I got seagulls, grape-like odor, musty odor, whooping cough, okay, is associated with a certain organism. X and V vector characteristics. And then vectors like sandfly, body lice, or tick. Make sure that you know what your vectors are, what organism these vectors are associated with. And then the next section is match the following diseases with the organism. So you're going to need to know the diseases as I lecture, as I give you your lectures. Like, for example, rice water stool, Malta fever, Carrion's disease, trench fever, cat scratch fever. I already told you that one. That's Pasteurella multocida. Tularemia, Pontiac fever, swimmer's ear. Okay, these are real terms and they're unique to certain organisms. Glanders, Brazilian purpuric fever. Okay, so make sure you do a collection of diseases, unusual terms as well. And then the third section here is match the following organism appearance with the appropriate organism. Okay, school of fish on the gram stain, cut glass, ground glass appearance. So there's cut glass and ground glass. Mercury droplets. One unique characteristic is it requires a 30-day incubation. 30-day incubation is brucella. Okay, safety pin on the gram stain looks like safety pins, and you already know clue cells. And then the last section on this matching test is match the following media with the organism. So TCBS is thiocitrate bile salt media. The color of this organism is yellow on TCBS or green on TCBS. And then there's the Gembeck. If you see Gembeck, you're looking for one specific organism, and that's Neisseria gonorrhea. Okay. And then BCYE, that's buffered charcoal yeast extract, is specific for going after another certain organism. Then there's charcoal-based selective media, and there's glucosystine blood agar. Okay, that seems like a lot, but like I said, all of these things are in the lecture as in my lectures is I highlighted them in red. Like I said, if it's red, it's important. It's red for a reason, okay? It's red for a reason, and that reason is you need to know about it. And then I'll make other comments. Make sure you know this, you'll be tested on it. If you hear those words, make sure you know this, you'll be tested on it. Put an asterisk by it. He said it's going to be on a test. Okay, so when you do your studying, make sure that's at least a given that you know that piece of information. Okay, so any questions at this point? Okay, if not, then I'm going to get into this first lecture, laboratory safety. I hope I didn't scare anybody away. I mean, as I sent this to you, I said, you know, I'm thinking this is a ton of information. Like I said, this microbiology class is, I teach at the CLS level. And when I took this class, it was pathogenic bacteriology. It was upper division at San Diego State. This, I mean, you guys are going to be MLTs, but you're getting CLS level information. So if you get into a CLS program later on down the line and you take microbiology again, you will be very well prepared, very, very well prepared, especially, and also too in hematology, because you know your anemias. Well, anyway, laboratory safety. Okay, final objective. You guys will demonstrate and apply standard precautions that they apply to the microbiology laboratory according to Osha. Osha is that safety organization, stands for Occupational Safety and Health Administration. Health Administration. Okay. Enabling objectives. State the role of OSHA, discuss components of the laboratory safety program. One thing about OSHA, when you hear that OSHA is coming to your laboratory, you want to be on your toes. You want to be on your toes, because if they find a discrepancy, one one simple discrepancy is, for example, regular trash. If they find a glass pipette thrown away in regular trash, that's a safety violation. And anybody have any idea of how much a safety violation is? How much it costs the organization if you do a safety violation like throwing glass or broken glass into regular trash as opposed to a sharps container? Anybody have any idea? Somebody take a guess.
Like 10,000. That's my guess.
Nope, that's low.
That's low.
That's
Oh my
low.
13,000.
13,000. This is not Price is Right. 1301, right? No, not 13,000. Anybody else venture to guess?
20,000.
Close. You can go a little higher.
30,000.
No, that's too high. $25,000. So if you have 5 hits from an OSHA inspector, you just cost the laboratory, or actually you cost your hospital $100,000. And can you imagine how embarrassed you would be if they found four violations? Another one is like if your instrument is pumping waste directly into the drain, and they ask you where does this drain lead to, and you say, oh, I don't know, I think it drains out into the bay. Guess what? Wrong answer. That's going to be a hit. So, and that's a major hit too, especially with safety and the EPA. So yeah, an OSHA hit will cost the organization $25,000. So when you're it's a good thing you guys are MLTs, but the CLSs are probably going to take the brunt of explaining why you have glass in your regular trash or things like that. Okay, so MLTs can be in the background and say, oh man, oh well, sucks to be that person, right? And then list of required practices: chemical safety, fire safety, electrical safety, handling of compressed gases. This is not all. I mean, there's other things like safety training that needs to be done. Like, for example, one of the big things is ergonomic safety. In the laboratory where I worked at, is like people were dropping like flies with injuries, like shoulder injuries and wrist injuries and arm injuries and carpal tunnel. Because they're doing the same thing, repetitive motion, over and over for 20, 30 years. Well, if you can imagine, if you're drawing like 40 to 50 patients a day, every single day, in a whole week, that's five times that, or think of it as a career. That's a lot of repetitive motion. And it's no wonder that people are out on these injuries, FMLA, or they're out because of an injury, or they have to have surgery. So there's a lot of safety things other than chemical, fire, electrical. There's ergonomic safety. There's even stress. Stress can be a safety issue as well. Okay, or threat management. If somebody comes into your laboratory saying that I don't like my laboratory result, or my doctor just told me I got cancer, and guess what, I'm not in the mood and I'm carrying a gun, you need to know how to handle yourself. And that's real. That can happen, where you have an irate patient, a really upset patient. They even have certain codes. Hospital have codes like code green or code gray or code black, if they have a gun. So threat management and threat safety has to be something that you need to be prepared for. So, and it's real, because if you're in a healthcare setting, how do you know that? A lot of times, especially if you draw blood, and we expect to be really cordial and polite to these patients. They say, oh, how you doing, sir? Or how you doing, ma'am? I hope you're having a nice day. And guess what? They just come from the doctor's office and they told her they got stage 4 cancer. You think they're going to be in the mood for how you doing? How it's a nice day today, or beautiful weather today, right? You think they're going to be in the mood? No, they're going to be in a really, really bad mood. So you're going to need to know how to deal with situations like that. I mean, there's ways to be polite and nice to a patient, but you'll have to learn, you have to learn how to not to overdo it. Okay, list of safety requirements in the microbiology laboratory, principles of biosafety, requirements of standard precautions. The biosafety laboratories, there's 4 levels of the BSL, biological safety laboratories. And that's like, you know, you heard in the news, the Wuhan laboratory, that's a level 4. And then of course in the microbiology, that's a level 1 or level 2. And then public health would be level 3. But the ones that do intense hardcore research, that's the biological safety level 4 laboratory. The types of BSC, so the BSL laboratories, there's 4 classes, 4 levels, as opposed to BSC. A BSC is a biological safety cabinet. Those are your hoods, okay? So basically the 3 types of hoods are the 2 open hoods. I mean, level 1 and level 2 are both open hoods, and they're low level handling of materials. The level 3 is actually a glove box, and it's enclosed where you actually insert your arms into these gloves and manipulate and handle the material underneath the hood. You never touch it. Your gloves are actually working on it. So I'll talk about that later. Causative agents of laboratory acquired infections. Laboratory acquired infections is real, okay? You can get sick from it, but you can also die from it, okay, from a laboratory acquired infection. And I experienced this personally because one of my previous supervisors, she was my supervisor, and then I had left. I had joined the Navy, but she remained as a supervisor until I found out that she died because of a laboratory acquired infection. So what happened was, you know, when you're dealing with these bacteria, you need to be careful. Okay, so what happened was, it was towards the end of the day, a blood culture came in, and it was like 325 or whatever. It was really close to the end of the day. She was setting up a gram stain on this blood culture bottle, and she was doing setting up a gram stain. So in doing so, not underneath the hood, when she went into the bottle, she created an aerosol, okay, and she inhaled the aerosol, and it turned out that that particular blood culture was positive for strep pneumo, and she caught it. She got sick and she never recovered. So that's a laboratory acquired infection. So she passed away, unfortunately, because she was a really nice microbiology supervisors. Okay, it's real. So state requirements for shipping biohazardous agents. If you see shipping, the government agency that's in charge of shipping and packaging is DOT, Department of Transportation. The different levels of laboratory response network. Laboratory response network is the level at which you can handle certain organisms, microbiology organisms, like a sentinel, reference, and then laboratory. I'll get into that later on. But it's a different level of handling microbiology specimens. OSHA, okay, OSHA was signed by President Nixon in 1970, and it's for work-related injuries. So I don't know if you have been keeping up with the COVID on the news, but they tried to make it seem like if you didn't get your vaccine, then it was going to be an OSHA violation, or if you didn't get your mask or whatever. I think it was the vaccine. If you didn't get your vaccine, OSHA was going to fine your organization, like Walmart or Sears or whatever. And so that was going to be a severe penalty until it was thrown out by OSHA. OSHA had no real jurisdiction because COVID is not a work-related injury. You don't get COVID, you go to work and catch COVID. You know, operating a forklift or stocking inventory, you don't get COVID doing that. So the whole issue about OSHA was thrown out, and that was for COVID. OSHA enforces their policies through inspection, site visits. Like I said, $25,000 for each hit that they find when visiting a laboratory. So, and it's they enforce their policies through inspection site visits. You learn a lot from their visits, training, safety training that's done, call-in centers, and posters. So there's a lot of communication that OSHA puts out so that we are well informed. Laboratory safety program, there's chemical safety, fire safety, electrical compressed gas exposure control. Okay, so like I said, laboratory safety does not encompass only these areas. It can be more like especially ergonomic safety. Eye washes. Okay, emergency eye wash and shower needs to be within 10 seconds away or 100 foot of work area. Now, I know it's not on this slide, but if you get a splash in your eye, make sure you know this, write this down. If you require using the eye wash station and you got something in your eye, you got an eye splash, you rinse your water, you rinse your eyes in the eye wash station for 15 minutes, okay? For 15 minutes, not 5, not 10, but 15 minutes, not 20, but 15 minutes. You'll be asked that, okay? So when I say things like that, make sure you write it down. Fire extinguishers and fire blankets should be readily available, and they also should be checked. Fire extinguishers are checked monthly. Fire blankets, the reason why they should be checked periodically, at least yearly, is because moths, if you're using a wool fire blanket, moths can get to the blanket and eat up your fire blanket. If you have a fire and you open up the blanket cabinet, it could be with it could have holes all over it, and that could be pretty embarrassing. So check the blankets to make sure that they're not moth eaten. Available spill kits, they have expiration dates. You need to make sure that your spill kits are current and up to date. Same with first aid supplies. You don't want to use old Band-Aids or old bacitracin that's expired. Make sure that everything is within the expiration date. Okay. In the laboratory, you should have 2 means of exit. For example, if by the entrance there's a fire, you need to be able to escape using the other exit. Fire detection system, like an alarm system with sprinklers. Okay, with regards to sprinklers, there is in your supply room, when you store boxes on shelves, it needs to be 18 inches. I know, again, it's not on here, but it needs to be 18 inches from the ceiling. And the reason is because you need to give clearance and have enough space for the sprinklers to sprinkle water. Windows must be closed and sealed. Self-closing doors. So when the alarm goes off, the doors are kept open by magnets. When the alarm goes off, then the magnet holding the door is released and the doors will self-close. Also too, there's a device. You open the door and then it'll close by itself. You should not remove those. I see some people because they like to keep the doors open. One thing is that you shouldn't prop doors open if it's designed to close, and 2, you shouldn't remove that device that closes the door. If I'm an inspector and I see that, then that would be a hit. If I see doors propped open, that would be a hit. Okay, it could be an OSHA hit. Okay, you're not using the door the way it was designed. Constant temperature in the laboratory between 68 and 72 degrees, and humidity between 40 and 60 degrees of humidity. And that's actually, those are the ambient conditions, but it's more for the instruments, because a large change in temperature or a large change in humidity can affect your instruments and QC. You'll notice that on hot days that your QC will go out of whack. So that's something to be careful about. Negative pressure. Negative pressure means that you have pressure within your room, but the air within your room is being exhausted. It's being exhausted, meaning that it's leaving through a vent rather than air coming into the room. If air is coming into the room, the ventilation, there's more air coming into the room than going out, and that's positive pressure. Negative pressure means you have more air leaving the room than air coming in. That's negative pressure, okay? So negative pressure is more air leaving is greater than more air coming in, all right? And positive pressure is more air coming in than the amount of air going out, being exhausted. Walls and surfaces must be easily cleaned. The rule for cleaning, if you're using bleach, is to use 10% bleach made fresh daily. I think I'll say that again later in this lecture, but if you're going to be using bleach, use 1 part to 10 with water, and you make it has to be made fresh daily. And the reason is because it can deteriorate with time. Bleach will deteriorate with time. Bench tops and furniture must be impervious to moisture. It shouldn't be able to trap water or any kind of moisture. Containment and risk assessment, okay, principles of biosafety, is the objective of any biosafety program is the containment of potentially harmful biological agents. If you're using or handling biological agents and you're underneath the hood, you got to make sure that you're not going to expose it externally. That's why the biological safety, the BSC cabinet, the one with the glove box, you want to keep that organism, that pathogen, contained inside the hood. But that doesn't mean that on the level 1 and the level 2, that means just because it's open that it can come out and onto the chemistry bench. No, you got to make sure that it's contained. I mean, there's a laminar airflow on those hoods that'll keep the organism or keep whatever you want to handle inside the hood. So that's containment. You don't want to expose your coworkers to any kind of pathogens that, by bringing it out. So that's containment and risk assessment. Risk assessment is how dangerous is the situation. So protect laboratory workers, the environment, and the public from exposure to infectious microorganisms. Okay. Process used to identify hazardous characteristics of a known infectious, potentially infectious agent. Laboratory and acquired infection, I talked about that. You want to minimize laboratory acquired infections. Be careful, be safe with these organisms, and you have to treat them as if they can really, really make you sick. All right. Universal precautions is having the thought that everything that you are handling is infectious and can cause harm to you. Like, for example, every specimen that you handle has HIV or has Ebola or has COVID. Okay, universal precautions is treating everything as if it is very, very infectious, it's a very infectious agent. So every laboratory should have this, and during each inspection, they'll be looking for the policy where it says you should not eat, drink, smoke, apply a cosmetic, etc., like contact lenses or contact with eyes, ears, and mouth. No smoking, no mouth pipetting. Those policies should be in effect in the laboratory. Also, to limit access to the laboratory. So you can't just have patients willy-nilly walking through your laboratory because it's a shortcut to the parking lot. So you need to limit access to the laboratory. Every time a person who you don't recognize comes into the laboratory and does not have an ID, you need to challenge them. Sir, can I help you? Are you lost? Okay, things like that. Limit access to the laboratory. Assume samples are infectious. That's the universal precautions. All samples are infectious. You need to be using your PPE. If there's a splash hazard, make sure you wear your goggles or face shields, lab coats, and gloves. Okay, wash your hands frequently. Sharps protocol. Don't throw your sharps into regular trash. And the sharps container needs to be no more than 2/3 full. Okay. Okay, so these specimens, these standard precautions don't apply to the following specimens, like stool nasal secretions, saliva, sputum, sweat, tears, vomit, unless it's grossly bloody. So these specific specimens here are not considered biohazardous. I think there's one missing in there, like urine. Urine is not considered biohazardous. You would think so, but it's not. So a stool specimen, nasal secretion, saliva, sputum, sweat, tears, vomit, unless it's grossly bloody. Because like when you change a diaper, you throw it into a biohazard trash, or when you blow your nose, you throw it into a biohazard container? No, you don't. You throw it into regular trash. So these specimens are not considered biohazardous. And by the way, you will be asked that. Okay. I'll give you one of these specimens and you'll tell me if it's biohazardous or not. No sniffing in the microbiology laboratory. Well, I have to confess, I sensed when I was on the bench in microbiology, I didn't sniff, but I detected odors that come from the cultures. Okay, because E. coli has a particular smell, Staph has a particular smell, Pseudomonas aeruginosa has a nice grape-like odor smell. Okay, so I don't sniff, but I can detect their specific odor. Wash benches before and after use, 10% bleach, made fresh daily. Okay, wash your hands often, wear your PPE, lab coats, and gloves. Okay, levels of containment, BSL 1 through BSL 4. So BSL 1 is appropriate for agents that are not known to cause disease. So it's handling microorganisms, but these are safe microorganisms like your staph strep. And BSL 2 is the same level as well. Appropriate for handling moderate risk agents that cause human disease. So usually the micro laboratories are usually BSL 1 or BSL 2. BSL 3 is when you're starting to use organisms like I mentioned when I went down the organism list, organisms that are potential bioterrorists. You want to rule them out, like Bacillus anthracis or Brucella or the Pseudomallei, etc. Those are bio safety laboratory 3 level that your laboratory should be at that level of containment. And then finally, BSL 4, that's like the Wuhan laboratory, where you're dealing with the coronavirus, or if you're dealing with Ebola virus, or if you're doing research on HIV, things like that. Those are the research laboratories, the exotic agents. This is the highest level of containment, okay? You're wearing those spacesuits with the respirator with the tank in the back. That's a biological safety laboratory 4. Okay, you are dealing with dangerous organisms. Okay, the hoods, biological safety cabinets, aka hood. Okay, so BSC, and it's designed to remove or minimize exposure to hazardous biological materials, and it provides containment. Okay, so that hood, again, is probably negative pressure because there's more air leaving that hood than the amount of air coming in. So negative pressure. So as that young lady over there is processing a sample there, there's no air blowing in her direction, but it's being vented out or going through a HEPA filter. So negative pressure, more air goes out than the amount of air coming in. So the biological safety cabinet provides, one of the purpose is to provide containment and also to remove or minimize exposure. So BSL has 4 levels. The cabinets have 3. Class 1 and 2, like I mentioned, are open in the front. So that laboratory there, that hood there, because it's open in the front, you see that where she can just access by putting her hands in, that's the opening. So a 1 and 2 are both open in the front. Open front, 1 and 2, and then this is class 1. It's air coming in, it circulates, and this here is your HEPA filter. HEPA is high efficiency particulate air purifier, high efficiency particulate air purifier. I think I had some notes here. Okay, eye wash, remember 15 minutes on the eye wash. HEPA is high efficiency particulate air filter, okay? This is class 1, open here. It's open in the front. Level 2, class 2 is also open in the front here. So HEPA filtered air, gets, this is a vacuum where it's going to take the air and channel it through these 2 HEPA filters here. 1, the filtered air goes to the outside, or 2, the air can return to the area where you're processing your specimens. So this is the direction of the air. It gets sucked down by this vacuum, and then it's pushed into these 2 HEPA filters. So this is class 2 HEPA filter. And then the third one, biological safety cabinet, provides the highest attainable level of protection. BSC3 is highest level of containment. So these circles here are, this is basically a glove box. When I worked with anaerobes, when I worked in one of the laboratories where I worked at, they had an anaerobe glove box, and it's pretty neat. Where you stick your hand through these circles, and actually you're entering, your hand enters a glove, and this is where you will handle the specimen. So this is used in a biological safety cabinet 3. Air is circulated, goes through the HEPA filter, and exhausted out. Okay, so this is the BSC level 3. It's closed. Okay, common causative agents of LAI, laboratory acquired infection. Brucella, I'll talk about that. Corynebacteria burnetii. Oh, I'm sorry, Coxiella burnetii. Hepatitis B virus, I won't be doing any virology lectures. Salmonella, I'll talk about. Francisella tularensis, MTB, Mycobacterium tuberculosis. B dermatitis, I'll talk about that. Venezuelan equine encephalitis. I won't be talking about that. Chlamydia psittaci. I won't be talking about Chlamydia psittaci too much. And Coccidioides immitis. This is the one that causes valley fever, C. immitis. I'll be talking about that in the mycology section. A modern study, shigellosis, Shigella, Salmonella, TB, brucellosis, and all of those I'll be talking about with the exception of hepatitis. Okay, shipping. Anytime you see on a test question shipping or packaging, this is the organization you need to be thinking about. Shipping biohazardous agents. There's specific training requirements that when you ship biological or biohazardous agents, there's certain training procedures that you need to learn. Packaging and shipping, again, make sure you see these 2 terms. And the policies are defined by the Department of Transportation. Okay. CDC writes regulations for the enforcement of CLIA. And CLIA stands for the Clinical Laboratory Improvement Act. Okay. Federal regulations, the CDC. You hear about the CDC on the news when, you know, they keep changing their policies on COVID and masking and vaccine and boosters, etc. Well, they changed their mind a lot. So I don't really have too much respect for the CDC. I did. I mean, when you're a microbiologist, your dream job, when you're a microbiologist, your dream job is to work for the CDC. But with the way recently how they're doing the policies, I don't want to get political. It's like, it's kind of wishy-washy. FDA clears products used by the laboratory. So in other words, every test that you perform in the laboratory has to be FDA approved, whether it's a glucometer test, whether it is a test for ALT, AST, a hematology test. all of those tests, all those instruments inside the laboratory, all the procedures have to be FDA approved. Okay, so they govern a lot in the laboratory. They clear the products used by the laboratory in diagnostic testing. Okay, EPA, when you're talking about waste disposal, that's the Environmental Protection Agency. EPA is the Environmental Protection Agency. So they want to know where you're disposing your waste. Okay, basically, are you harming the environment? Like I said, the inspector will say, I noticed that your waste is going down the drain, and where's that drain lead to? So it better lead to an area that's collecting waste that'll be treated later on. But if you say it's leading to I'm dumping this waste into the San Diego Bay, that's the wrong answer. EPA will jump all over you. So they want to know if what you're doing is harming the environment, the Environmental Protection Agency, how you're disposing of toxic waste. OIG is monitoring laboratory for fraud, waste, and abuse. And this is the one where this organization is the one where your laboratory billing practices, like patients come into the laboratory bills them. Okay, so and then there's we can get into things. They look for things like Medicare fraud and insurance fraud. So that's what the OIG stands for Office of the Inspector General. OIG stands for the Office of the Inspector General. Okay. Okay, the Laboratory Response Network. Okay, there's 3 levels. The lowest level is the Sentinel level. And these laboratories have the ability to rule out bioterrorist threat organisms. So it's a low-level detection of bioterrorist organisms. It's low level. You can detect it if you have a suspicion that it may be anthrax or it may be brucella, then you need to forward it on to the next higher level. So the Sentinel level is the lowest level, like the hospital laboratory. If you have a suspicious organism, like I think it's anthrax or I think it's brucella, then you send it from Sentinel to the reference laboratory. And these laboratories are like the public health laboratory, the state laboratory, okay? And if they do think, or they have a pretty good suspicion that they're confident that it is anthrax or it is brucella organism, then they will send it to the national. The reference laboratories, these reference laboratories, especially the reference and the national, can use BSL 3, okay? BSL 3 or better, okay? Or it could be a BSL 4. And at the national level, this includes the CDC and the U.S. Army Medical Research Institute of Infectious Diseases, USAMRIID, okay, USAMRIID, CDC and USAMRIID. This is the one where that definitely is anthrax, and they're going to investigate where did the anthrax come from, who planted it there, what country, if it's an international issue. The national level of the laboratory response network is the highest, okay? And they use BSL level 4, like I said, the jumpsuits with the respirator in the back, okay? You see when like people, the scientists in the Wuhan laboratory, they're all in these spacesuits. That laboratory is a BSL level 4, okay? And it serves as the final authority in the evaluation potential bioterrorist specimens. Okay. Reading assignments. Throughout the lecture, I tried accessing these hyperlinks and I had trouble. Maybe, hopefully, if you can get into those hyperlinks, then maybe you'll be more successful. Some more reading assignments, some sites that you can try to open up for additional information. Okay. So that was lesson 1. So microbiology fields of study. Okay, the student will list and describe fields of study included in microbiology. Okay, so you got bacteriology. So as I went down the list of organisms that we're going to be learning about this semester, bacteriology, okay, that's one field of study. And then the next field of study is mycobacteriology. Those are your acid-fast bacteria, AFB. Those are your AFBs, and it's acid fast because of the lipid content in the cell wall. You can't gram stain, you can't get good gram stains from AFB, okay? And then mycology, you got your yeast and your fuzzies. Okay, so when I say fuzzy, that's why I had this picture here. Does anybody know who this gentleman is? Who is this gentleman? So anybody?
Don't see anything.
Say that again.
I
What's
don't
his
see
name?
anything.
One more time.
I can't see it.
Oh, you can't see it? Okay, let me expand it then. Rudy, you know who this is.
I just see a gray background.
Are you serious? You can't see him? You can't see this? You
No,
guys, you cannot
it's-
see this.
no.
Okay, all right. Anyway. Anybody know Don King? You know who Don
The
King
name?
is. Don King, he's a boxing promoter. One of his trademarks is his hair, and his hair looks, it's like it's up and it's fuzzy. So whenever I think of fuzzies in mycology, I think about him. I don't mean to be mean or anything that he makes me think about funguses, but especially the dimorphic fungus. You can have the yeast colonies, and then you can have the fuzzies. Okay, and then virology. I'm not going to talk about virology this semester. And then parasitology. Like I said, we're going to go through a bunch of parasites: the protozoa, the nematodes, the roundworms, the flatworms, the cestodes, and the trematodes. And that'll be it. Everything below that, the pentastomats, the acanthocephala, arthropods. Arthropod vectors are important in parasitology. So we'll talk about arthropod vectors. Third is the microbiology. Lesson 3 is the microbiology organization, and I'm going to talk about the chain of command within the microbiology laboratory. And first you have the centralized facilities, which is located in the laboratory. And then you have the different types of testing. The physician office laboratory, which is a small laboratory. Doctor sets up a clinic and he wants to have a little laboratory where you can do wave testing. Then you have ancillary outpatient hospital clinics where you don't have any inpatients, but you have outpatient draw stations, which can also have an urgent care. And then you have point of care testing, where you can do glucometer testing or strep throat testing, or you can do COVID testing. I mean, COVID testing can be a wave test, okay? That's point of care. Based on the following space requirements and organization. Space requirements and organization, it's based on the organization and staffing. So you want to have a large enough space if you have a large staff, and you don't want to have a small space with a large number of personnel. And that's one of the things that on an inspection, they're going to evaluate if you have enough space to do the testing that you provide. The test to perform, that's really important. Available equipment. If you have enough equipment to do the testing that you're providing to your patients, you have to have adequate electricity, adequate plumbing. I mean, do you have sinks in the blood drawing area or adequate sinks in the laboratory? Do you have enough 220 outlets as needed, or 110 outlets where you don't have to use extension cords? Air handling requirements, if you have good ventilation. Safety equipment, that's mandatory. You need to have eye wash stations, you need to have eye showers, and you need to have the fire extinguishers. Waste treatment requirements, so make sure that you're not dumping your waste directly into the bay, that the water, that the waste from your instruments are contained and handled properly, and containment requirements. The microbiology should have, in their laboratory, should have an area where you receive and accession specimens. That's true for any laboratory, but you have a receiving area, an accessioning and processing area. Then after that, in microbiology, you need to have staining like microscopy, special microscopy, to evaluate specimen acceptability. Sections in the laboratory include waste disposal. So as the CLS is done reading their cultures, they throw their junk cultures away into the waste, into their biohazardous waste. Then they bag it up, and that waste has to be put into a special area for waste disposal. Otherwise, the laboratory is going to smell. Media prep and glassware washing could be another area in the laboratory. Isolation room for processing AFBs. Okay, so when you process AFBs, you can actually, that another laboratory acquired infection. The centrifuge that you use to process the AFBs has to have, on the buckets, has to have a cap, a screw cap on each of the buckets. And when you centrifuge it, when you turn on the centrifuge, that centrifuge has to be inside of kind of like a closet. So the laboratory where I trained, we processed AFBs. We had caps that screwed onto the buckets on the centrifuge. And then once we turned on the centrifuge, then we closed the door. It was like a closet that the centrifuge was in. For molecular diagnostics, you need to have separate rooms because for PCR testing, contamination is a big issue. Sections are microbiology laboratory sections. Benches are for routine workups. Like I said, the blood culture, the routine culture, CSF, blood and urine culture, those are the different benches that you can be working in. Offices for administrative personnel, record storage for your results, a conference room where you have meetings, and a lunch break room. Okay, I'm not going to go over the floor plan. Chain of command starts at the top with a director, then a supervisor, then the technologist, which is a CLS, then the MLTs, that would be you, then the lab assistants, those are the ones that will be doing the planting, and administrative support, which is the clerk. QA, each department or each laboratory, not only for microbiology, should have a QA, a quality assurance section. And that's in microbiology, it's to track unacceptable specimens, contaminated specimens, the amount of workload that you do, mislabeled specimen, that's also a QA monitor. In fact, information technology. Okay, so the laboratory system that you're on in the laboratory, it's called the LIS, the Laboratory Information System, like Cerner. Cerner is an LIS, or a Meditech. That's an LIS. It's a laboratory information system. Now that LIS feeds to a larger system, and it's called the Hospital Information System. That's the HIS. And the HIS could be like Epic or Health Connect. Okay, so what that does, it receives information from the laboratory about your results. So the LIS processes from the instruments into the LIS. Those are the results. It has patient's name, medical record number, etc. And then what it does, it sends that information from the LIS to the HIS. And the HIS is what the doctors use. It's what the administration uses. Okay, so that's the bigger picture. It's the HIS. So that's information technology. When you see logistics, all that is a supply chain. Okay, your supply, your inventory, whether you use just-in-time inventory, make sure your inventory monitors your expiration dates, and then you have your housekeeping staff. It's really important to have network with the housekeeping staff because they will make sure that your biological waste does not accumulate, because I'll tell you that it really makes your laboratory stink if it accumulates. And that's it for lecture 1. Okay, are there any questions? No? No questions. A lot of information. Okay, so tomorrow I'll do lecture 2 in the laboratory face-to-face. And this lecture I recorded, but tomorrow's lecture, since I'm face-to-face, it will